All right, students, so this video is going to show you all how to perform the t-test, both a one-sample t-test, and later I'm going to show you how to do a two-sample t-test in Excel. Okay. So the variable that I'm going to use to perform the t-test is child del, which is the ideal number of children. So I'm going to go ahead and copy this. I'm going to open up a new sheet. I'm going to paste it in that new sheet. And then later on, what I'm also going to do is I'm going to show you how to compare the ideal number of children for males versus females. So I'm also going to need to copy the variable sex. I'm going to paste it on this new sheet. I'm going to paste it a little bit over here. Okay, so now that I've copied these two variables to a new sheet, if you forgot, one of the reasons why we always copy variables to a new sheet is because we don't want to alter our original data. We just want to keep it as is. So now that I have this on this new sheet, I'm going to start altering it in the way that's necessary. So one of the first things that I need to do is everybody answered the sex question. So all the respondents, I said I'm either a male or a female. So everybody's been coded as one or two. So I don't need to do anything to that variable. But what I do need to do is I need to get rid of the missing cases from the variable child del. So what I need to do here is I need to find out what numbers are missing values. So I need to go to the code book. So I'm going to jump over to the code book. And I'm going to see that child del, the missing values are -1, 8, and 9. So I'm going to remove those three. But see, nobody said don't know or no answer. So there was no 9. So I can just kind of skip the 9. So I'm going to replace the -1 and the 8. So the way I do that is I come up to the variable, I highlight all of them, and I press Control F. So I'm going to replace -1 with just nothing. I got rid of all 483 of those, and I think the other one was 8. So I'm going to replace all those with nothing. So I replaced all the missing variables with nothing. Okay. So what I need to do now is I need to come over to this data section, and I need to find this data analysis tab. I'm going to click on this. Okay. And then I'm not going to come over to descriptive statistics. I'm going to come over to a t-test. I'm going to find two sample t-tests assuming unequal variances. So this is the way you would do it if you have if you're doing a one sample t-test. Now the thing about Excel is that Excel doesn't have the ability, or for some reason doesn't have the ability to do a one sample t-test. So you kind of need to start it off with a two sample t-test. So again, assuming that we have a one sample t-test, what we're doing is we have a hypothesis H1. So we're saying that the mu of one group, here we're not going to specify direction, we're just going to say is not equal to some specified value. And the specified value we're going to have is 2. So we're going to see whether or not the mean ideal number of children is equal to 2. Okay, and then the null hypothesis would say that the mean ideal number of children within this sample from the GSS is equal to 2. So the null hypothesis would say that the mean ideal number of children is equal to 2. So this would be our some specified value, but like I said, because Excel can't do a one sample t-test, we need to do something else. Now, in order to do this something else, what do we need to do? We need to calculate a dummy variable. So I wanted to show you that there is no one sample t-test. So what we need to do is create a dummy variable. So what do? We come over here, we click dummy. And then we're just going to put 0 here and 0 here. That's all we need to do to create a dummy variable. Okay? Because like I said, it can't do a one sample t-test, so we need to do a two sample t-test. Come back to data analysis, and we're going to come over, find t-test two sample assuming unequal variances. So we're going to click on this and we're going to press OK. Okay, so now that we have that, we need to input variable one range, and we're just going to get everybody who answered child del, which is the ideal number of children. So we're going to click this, scroll down, and get everybody who actually answered this question. Okay, so we got all the respondents. I'm gonna click this in there. Now what I need to do is I need to go find variable 2, and then the way I'm gonna find that is, that's just the dummy variable, so I'm just gonna select these two cases. Enter that in. Now again, the hypothesized mean difference, I'm gonna put here 2, okay, because that is the specified value that I'm gonna be comparing it to, okay. Now, the alpha level is 0.05. Now, I could alter this. I could make it 0.01. I could make it 0.001. So what it's going to do is going to give me the T critical for that specific alpha level. Obviously, we want our T statistic to be either at or above the T critical in order to reject the null hypothesis. If our T statistic is below that T critical, then we're going to fail to reject. Okay, so I think we have everything that we need except for the output range. So I'm just going to specify where I want this to go, and I'll just put it here. And then we're going to press OK. Okay, so now we have quite a bit of information up here. Some of it's necessary, but this whole variable 2 is actually not necessary because that was just a dummy variable. So I'm just going to delete that whole column. And I want to expand this a little bit just so I can read it. So we see that the mean for this variable is Chaldo 2.59. Variance is 1 approximately. So there's 884 observations because there's 884 people actually answered the question. Okay, so there's 884 people actually answered the question. The hypothesized mean difference is 2. So our degrees of freedom is 883. If you remember how to calculate degrees of freedom, we take n minus 1 for one sample t-test. So 884 minus 1 gives us 883. So this is our T statistic. So our T statistic, or our T obtained, is 17 point, let's just round to 17.66. And then, so this is the T critical for a one-tailed test, and this is the T critical for a two-tailed test, which matches up pretty closely to what we have here if we look at our T table. So for a one-tailed test for a 0.05 alpha level, the T critical is 1.645, which is about what you see here, which is 1.645 approximately, right? And then for a two-tailed test, 1.96. If we come back here, we see for a two-tailed test, 0.05 alpha is 1.96, right? Now we're using this infinity symbol because our degrees of freedom is 883. So when our degrees of freedom is 120 and above, we're just going to use that infinity symbol. So knowing that we have a T statistic, or T obtained, of 17.66, we know that it's above our T critical for a one-tailed and it's above our T critical for a two-tailed. So we would be rejecting the null hypothesis at the 0.05 alpha level. Now, you could also check it for the 0.01 and the 0.001 alpha level. So if you look at a two-tailed test for a 0.01 alpha level, the T critical will be 2.576. Our T obtained of 17, point whatever is obviously way higher than this. And our T obtained is way higher than the 3.291. So in this situation, we know that we can reject the null hypothesis at the 0.05, 0.01, and then the 0.001 alpha level. Now this information right here, this P is T for a one-tailed test, it's just giving you the significance levels for the one-tailed test, significance level for a two-tailed test. But it's in exponents and it's negative, so it means that the numbers are going 2, 3, 4, 5, 6 backwards. So the p-value is way below 0.000. So having said that, we know that we can reject at 0.05, 0.01, or 0.001 alpha level for both a one-tailed and a two-tailed test. So you can do it two ways. You can look at this, and it'll tell you the p-value, but like I said, it's going negative exponent, so you need to go both times. Now, how would you do this if you're doing a two-tailed test and you actually have two samples? Well, so let's just say that we have a two-sample t-test that we're going to conduct. We want to know whether, so this was a one-sample t-test. Let's just say we want to know whether or not males and females are going to have different ideal number of children that they want, right? So we can be specific in the sense that we can say that males, so we can write mu is 1, mu of 1, so we'll just say mu, the first mu, or the first population mean is equal, the first sample is males, okay? We could say that the mean ideal number of children for males is less than the mean ideal number of children for females. Is it? I don't know, but we're gonna go about testing it, right? And then the null hypothesis would say that the mean ideal number of children for males is equal to the mean ideal number of children for females. Okay, so here we have a direction and we're going to do a two-tailed test. Okay, so what we need to do is we need to jump back here. And because we're actually going to use two different samples, I'm just going to go ahead and erase this dummy variable. Okay, so I have child L and then sex right next to it. Like I said, I don't really need to clean up, I don't need to clean up the variable sex. And the reason why I don't need to clean up the variable sex is because it's, for the most part, been there's no missing cases. So everybody answered either they're male or female. But what I do need to do is I need to sort these variables. What I'm going to do is I'm going to highlight both and I'm going to come over to sort. And then I'm going to sort by sex. I'm going to do it for values. I'm going to do it smallest to largest. Press OK. Now what we see here is that all the males are presented first. And then eventually we'll get down to all the females, okay? Now I know 1 represents males and I know 2 represents females. How do I know that? Because if I come over to the code book and I find the variable sex, I again see that 1 is male and then 2 is female. So that's how I know that when I'm looking at the 1s, it's male, and when I'm looking at 2, it's female. Okay. Now that I have that and I have everything sorted, what I'm going to do is I'm going to jump back to data analysis. And then I'm going to come here and I'm going to do a t-test, a 2 sample, assuming that the variances are actually equal this time. So I'm going to press this and I'm going to press OK. Now the variable range, so variable 1 range, I'm going to go over here to child L, and I'm going to input everybody who is for this 1. So I'm going to do it for everybody that's labeled as 1, so everybody who is a male. I'm going to do it till I get all the 1s or all the males. Okay, so I got all the males. I'm going to input that. Now I need to do the exact same thing for females as well. But again, instead of doing it for 1s, I'm going to do this for the 2s. So I see that the 2s start here, and I'm going to start scrolling down until I get all the 2s or all the females. Went a little bit too far. Okay, so I got everybody who identified themselves as a 2 or as a female. So that'll be variable 1 range, will be variable 2 range. Here I don't need a hypothesized mean difference because, like I said, I'm going to compare the mean of 1 sample, which is the males, to the mean of the second sample, which are the females. Now I need to go about finding my output range. So I'm just going to put that right below this one, and I'm going to output range is going to be here. Now what I think accidentally happened is that this cell jumped into the variable 1 range, so I'm going to get rid of that, and I need to redo this for the males. So that's my actual input range. Input range for 1. All right, got this. I'm going to press OK. All right, now it provided me the two sample t-tests I'm going to put here is for males, because that's variable 1, and then females, that's variable 2. Now, there's quite a bit of stuff here. So we can see if we're comparing the mean difference between males and females. For males, the mean is 2.59, and then I guess if you keep on going, it's going to be 2.5929, and so on and so forth. And then for females, it's also 2.59, but then if you keep on going, 465. Now, I can just look at these two means, and I can tell that there's not a substantial difference between the two means of males and females. Okay, so just eyeballing it, I can tell you already, there's not going to be a substantial difference. Okay, but the way we actually determine mathematically whether or not there's a substantial difference is by looking at the t statistic, or the t obtained, and then comparing it to the t critical. Now, as we can see, our t statistic, or our t obtained, is negative 0.02. So it's a negative 0.02. Now, if you're thinking to yourself, well, why is it a negative? Well, again, our original research hypothesis was that the mean for males is going to be lower than the mean for females. So that's why we have a negative number. So it's actually consistent with our original research hypothesis. So that negative is good. But that t is so low, the negative 0.02 is not higher than our t critical. So because our t obtained is lower than our t critical, we're going to fail to reject at the 0.05 alpha level for a one-tailed test. And then we're also going to fail to reject at the 0.05 alpha level for a two-tailed test. But we had a one-tailed test because obviously, like I said, we specified direction here. So again, and then you can also look at the p value is 0.49 for one-tailed test, which again, you need to have your p-value either 0.05 or below, which we don't have that. So this is data tells us that what we're going to have is we're going to fail to reject the null hypothesis. And the reason why we fail to reject our null hypothesis is because our t statistic is below our t critical, and our p-value is higher than 0.05 alpha level. So I did males, females. Yeah, so that's how you go about doing a one sample t-test. The first thing you need to do is create a dummy variable, and then if you do a two sample t-test, you'd go about doing it that way. Quite a long process, but again, if you missed anything, just go ahead and rewind this video and try to watch it over.